Okay, so as I understood your question, it was about how to apply the stamp-based approaches, either STPA or CAST, inside an airline operations type context, and also with considering safety management systems or the development of a safety management system. So the first thing I'll talk about is incident and accident investigations. So you could use CAST accident analysis to look at a specific event. So you mentioned the movement of aircraft on the ground and parking and security and stuff like that. So you could start by looking at that specific situation. So the control, well, think about the particular hazard that you're interested in or hazards. So if we're talking about, movement of aircraft on the ground, either not necessarily taxiing, but unpowered movement, so to speak, that would be your control process. You could then start to look at, well, what are the conceptual actuators and sensors? So you could say that some people might be some actuators, or if you looked at that from a more conceptual abstract perspective, your people involved would be a series of controllers. So if you have more than one person, you'd have more than one controller. You would have some procedures on how to do those activities. Now, they would be types of control actions from the operations management, however you describe that controller. As part of that, I'd like to expect that there'll be some training and competencies, perhaps some type of auditing or some kind of validation that the people involved are, appropriately skilled and experienced. And they can be considered in the higher level, sort of depending on how many levels of hierarchy you want to look at. Now, you'll have seen in the training, generally, I talk about, start with 3 controllers, 3 levels. So think about the hazards, think about the control process, the physical process, what that might be. Bearing in mind, depending on what you're looking at, you might elect to have more than one physical process if you want to start looking more broadly. And then look at, well, what's the first level of control, direct control? Is it, in this case, purely humans interacting with aircraft and equipment, tugs and such like? Or is there some level of automation between it? Now, I've seen recently use of remote control tugs, those really small things that go and pick an aircraft up and move it around. Now, the use of those tools presents an extra level of detail in the control structure, because now instead of directly interfacing with the aircraft, the operator, the mover, is actually interfacing through another layer of control. And that extra layer of control might make things more convenient for the operator, but it introduces new and interesting ways of having, damaging aircraft or causing accidents. So you could use it for that particular situation. And then once you've got experience in defining the hazards, defining the physical process that you're interested in, and then defining the control structures and refining it to a level of detail and depth or height that is appropriate, you can then use those skills and apply it to other operational scenarios, such as loading, CG, Loadmaster type stuff.
But I do have a question, and perhaps just going back to basics a little bit, the difference between CAST and STPA, from my understanding, is that you do CAST once an occurrence has occurred.
Yes.
And STPA, perhaps when you're thinking about hazard identification and how the process is designed in terms to control safety outcomes, right?
Yes, that's correct.
So for example, if we had an event in which the aircraft was parked, but they didn't apply the brake, and the aircraft just moved towards and smashed into a building,
Yes.
That's the type of thing that you would start using with CAST, starting in terms of describing the physical event or the chain of occurrences, and then in typical stuff that you're used to do, but also you, based on that, you start adding the level of controls or the control hierarchy, but based on that specific occurrence, right? It's not like the whole process, it's just a specific event to see how the actual different ways of it working occurred. Is that correct?
Yes, that is. So fundamentally, all of the stamp-based processes, stamp-based analysis processes, so whether it's STPA, CAST, or the other two, fundamentally, they all have three phases, or the way I describe it and teach it, fundamentally, they have three phases. The first is a foundation phase, and this is essentially preparing yourself and information ready to do the analysis. As part of that, you'll define the, if you're talking about a real accident or a postulated accident, you'll define your losses, you'll define your associated hazards. If you've had a real accident or incident, it's clear what the loss is, it's clear what the hazards are. And then the next step is to define the high-level safety constraint and then how that relates to the control structure model. Now, when you're analyzing a real accident as part of a CAST accident analysis, you've sort of already got information already available that gives you a starting point. Whereas when you're doing the foundation phase for STPA, you're almost sort of setting the scene yourself and moving forward from that point of relative certainty. Then you move into what I call the modeling phase, which is where you create the control structure model. Now, the activity of creating a control structure model is the same for STPA and CAST. The only difference is because when you're doing CAST, you're looking at a specific event. You know what controllers are involved in that particular situation. Whereas when you do an STPA, you're essentially defining that yourself, and you make some assumptions about that. You know, you may assume, like in the Uber self-drive car situation, you had a situation where you had two operators on board and looking after the vehicle operation. And then later on in the future, that control structure was changed. So you only had one operator in charge of that operation. Now, fundamentally, the two control structures are different, and they have, you know, they relate to the same hazards associated with movement of the vehicle. But because the control structure has changed and there's now, you know, one operator instead of two, that has different potential scenarios that relate to the accident. Now, of course, when you're doing a real accident analysis, you have to recognize there's a control structure that the designer or operator intended, and then there's the control structure that actually existed when the accident occurred. And if the procedure says we need two operators involved in this process, but on this day, one person was on holiday or having a sleep or whatever, and it was only one operator, we have to recognize the variance between those two control structures. And also it depends how detailed your investigation goes, because as part of your accident investigation, you may elect not to go back and look at the original safety analysis or the risk assessment. You know, so if you're only looking, if there is one, I mean, we could talk about that topic a lot. So when you do your CAST control structure modeling, you have to be mindful of, are we modeling work as imagined or supposed to be versus the reality? And it might be worth modeling both of those, you know, because then you'll be able to see where the delta is between what we thought was supposed to happen and what actually happened. And if you've seen any of my Uberlingen mid-air collision accident videos, I specifically highlight that we have one air traffic controller looking after two sectors of airspace. Now, that's perfectly fine if the traffic density is low, but if you start having, you know, disruptions, more traffic or traffic when you don't expect it or other technical issues, then all of a sudden that puts you on the path to a serious accident. So that's from a modeling phase perspective, that's the difference with CAST and STPA. STPA, you're either trying to model it as you want it to be and how it's supposed to be in operations, whereas CAST, you're potentially looking at work as imagined versus work as done. Now, the other thing about
the way they get activated differs, because the way I understand it is CAST is based on a specific occurrence, but STPA in terms of developing scenarios and thinking different possible ways that the system might behave itself. Is that correct?
Yeah, that's right. Yeah. So if you imagine STPA is all possible scenarios that lead to that same accident, whereas CAST is narrow, specific on the particular path. But the beauty of the STPA, the beauty of the stamp-based approach, building a control structure, is you can see what happened in this accident, but you can also potentially see how that accident could have been caused by other scenarios that just so happened didn't occur on this occasion. Or if you're looking at a near miss, and this is the real beauty of it, if you have a near miss, it is telling you that there's something not right with the control structure. So if you have a near miss and nobody's been killed or anything like that, you can go back and investigate that near miss in more detail and ask people, why did it make sense for you to behave in this way? We're not here to judge you. We just need to understand so that we can see what else we do. As part of that CAST investigation, you can start to identify other potential causes of that accident. Now, like with the Uber or with the Uberlingen accidents, where we have one operator instead of two, quite clearly you can see, well, this accident was related to having only one operator. What other accidents could also occur from that same deficiency in the control structure? So you sort of, you get more bang for your buck by doing a CAST investigation.
Absolutely.
But also you have to be, sorry, go on.
And the way, no, it's okay. And the way I approached it at the beginning, as I told you, once I just started reading and knowing about CAST, is it actually made sense to go deeper into STPA. Because
exactly,
what I believe is basically that if you want to have a safe operation, you need to make sure it's safe by design.
Yes.
I think what is lacking in terms of SMS tools, which I believe they fit perfectly, is we have tools for CAST, which is the operational execution, but we don't really have tools for making sure that the processes that we're designing for marshalling, for example, really are safe, taking into account the specific context. So yeah, I think that's the way I want to improve the SMS models I tend to implement in the airlines I work with, or the industries I work with, giving a lot more focus on the design of the operation, which yes. I really haven't seen many tools making sure that happens. I mean, we see tools for investigation, for reporting, for management of change, absolutely. But the missing piece is how do we make sure in a systematic manner to have the effectively designed processes for delivering safe operations.
Exactly. Well, that goes into the final part of the stamp-based approach, the analysis bit. And I suppose you could say design and analysis and design, but I'll talk about design in a moment. So once you've got your control structure model, or models, depending how complex the thing is that you're looking at, and the different levels of abstraction or different perspectives you require for it to make sense, you then step into the analysis phase. And this is where STPA and CAST are different. So with STPA, you start by looking at unsafe control actions. You start by looking at control actions for each of the controllers, and of those control actions, which are so-called unsafe control actions. And then the second part of STPA is essentially looking at, well, how do those unsafe control actions come about? What's caused those? And they could be a mixture of things related to, failures. That's where your failure-related analysis fits in. But it could be due to people had a belief. You mentioned, the brake was not set on the aircraft. Well, why would it make sense for the person to leave the aircraft if the brakes are not set? So you can start looking at, well, what must their mental model have been? And if you can interview the person as part of CAST, then great. Whereas when you're doing an STPA, you don't necessarily have that person to speak to, but you can postulate, well, if their mental model has not been updated, that the brakes are not applied, why would that be? And what mitigations could we put in place? How could we make sure that their mental model is appropriately updated? Do we need to put flags in place, or, remove before flight type tags? I don't know if that would be relevant in that particular case, but, that's where you start to analyze the problem, define the problem, and then start thinking about the potential solutions. And this is where the analysis and then into design really comes from an STPA perspective. But you have to be quite disciplined in your thinking and approach, because if we're all guilty of it. It's especially men, not being sexist or anything, but especially men. If somebody comes to us with a problem, we want to solve the problem. That's our natural, let's solve the problem. And so when you're doing the analysis, you have to be sort of, disciplined in your thinking, not to just jump to the solution, because the solution that you naturally come up with might not be the most effective. In fact, it might actually introduce other potential causes of that same accident or even other accidents. And that's why change is really important. There was a fan cowl door loss accident that I looked at a few years ago at Heathrow. And one of the contributors to that was the removal of the tech logs from on board the aircraft. And they were removed from the aircraft and put in an office many, potentially miles away from the aircraft because of the size of the airport. And the physical presence of those technical logs on the flight deck, when the maintainer looks at it, they can see the tail number on the log. So if that log is on the aircraft, they are confident that they're, maintaining the correct aircraft. But if you physically remove that log and put it in an office, they don't have that feedback. So there is no opportunity to update their mental model and confirm to them that they're maintaining the correct aircraft. So there is that. So so from an STPA, you're looking at the unsafe control actions. Then you're looking at how those unsafe control actions can come about. And then if you want to then jump into looking at design solutions or opportunities for changes, you can do that, but you have to be very disciplined because we don't want to introduce, faults into the analysis by being undisciplined. And of course, this sort of shows the utility of the STPA analysis because you could use it as a standalone safety assessment and then specify requirements for the design process then to do something with. Or if you include STPA as part of the design process, you can shorten that time from defining problems and defining solutions to then fixing them. But obviously, depending on how complex your system is, how complex the control loops are, you have to manage that. You don't want to go completely crazy and try and solve all the problems straight away. There's only so much information you can keep in your head at once. So
yeah, totally. No, and perhaps what we're looking for, and there's little resources to do this, and perhaps you don't want to, complicate people in the front line or operational managers.
Yes.
But what you would really think or what you should really have, I think, is perhaps a base in terms of work is imagined, but really structured to make sure that whenever we have an accident or incident, we can actually compare the two.
Yes.
Or if having or introducing a new change, we can activate the management of change process based on that predefined model.
Yes.
It doesn't have to be like very, very meticulous or specific, but we can start in a period of 3 years to go from general to specific.
Yes, absolutely.
And I think that really helps in terms of making sure that safety management efforts are actually working. Because right now, with today, what I feel is that we're putting band-aids to a balloon that is, the air is going out, but we really don't know the shape of the balloon. We need to make sure that the shape is adequate and not just keep putting the band-aids. So this is what really got me about STPA and the way I want to start working with it is perhaps based on airline processes, which are, they exist already, everything has been invented. Try to develop a specific systematic approach for introducing STPA to those processes and make sure we have the flows and the controls to make sure that we can compare that. I don't know if you've seen that before in some airlines, because most of the examples you get to see from STPA are related to specific like machinery or
equipment, products.
Not really so much organizational processes. So I'm really interested in knowing how does that look and if that's worth the effort, which I believe it is, but
it's a big challenge because STAMP STPA is essentially born in systems engineering and system safety engineering, and that is typically focused on the effort of creating a technical product, not necessarily an organization or a service. But the principles of the control structure can be applied across the technical and the social technical. But of course, when you create that control structure model, you have to be mindful that an actual organization of people is dynamic and gray and a bit like a cloud. It's not necessarily concrete unless you as the system, the organization designer, the senior leadership, you decide to put that structure in place. And in safety management systems, typically you have the doers and the checkers, and then you might even have an independent system monitor of some description. And that is a control structure architecture that is mandated by regulations in some countries, yes. Like with EASA bringing along the new regulatory changes because of ICAO Annex 19, they are sort of saying, well, you know, broadly, you need these pillars of a safety management system. Those pillars align to certain elements in a control structure. And then it's up to those organizations that are regulated to those requirements to then design and architect their organization to fit the intent of those requirements. Yes. But of course, the people that are generally tasked with doing that, they've already got an existing organization, and it's not necessarily documented. You know, absolutely. People have done things the way they've done it for years, and when so-and-so retires, that part of the structure disappears. So who picks up that work? How is it defined? And that is, you know, it's a bit loose is the best way I can describe it. And so by thinking about the control structure, what does it need to look like to fulfill these particular functions? Bearing in mind, because it's safety guided design, we have to be clear about what are the hazards that we're interested in. And so an organization that, you know, if you've got a maintenance organization, one of the hazards related to that is the release of an unsafe aircraft. You know, whatever unsafe means in that context. There may be other hazards such as, you know, fire and explosion in the hangar. Now, the control structure for the overall organization will be common, but when you start looking at specific hazards and specific physical processes, they'll have different specific elements for those areas. Now, I'm not suggesting you should try and model a control structure for every hazard in your operation, because it'd be huge, but just the activity of thinking about, well, what does the control structure look like for this hazard? You know, who are the frontline operators? What equipment and data do they use and potentially need to use? How does that affect the line management and then senior management, and then the interface with the auditors, the regulators, and everybody? So, but just by thinking about those things and, you know, mapping the control structure, you know, using post-it notes so you can move things around, you start to realize, oh, actually, you know, there's quite a few people that actually have responsibilities spread across the control structure. And then you can start asking questions about common causes. You know, if we've got this one person who's very experienced and they become the go-to person that makes decisions, is the decision making separate to the independent assessment, or is it evolved over time to become the same person or team? You know, so you can almost do a common mode analysis, like in aircraft design, systems design, because ultimately you've got your control structure model, and then you're looking at, well, how is that model implemented? Who are the organizations? Who are the people? You know, how do they share information? How do they communicate with each other? How do we make sure that if so-and-so is off sick or on holiday or retired, that experience is not lost from the control structure? It's maintained. You know, so there's, I mean, it's basically a design tool if you want to use it that way.
No, and the thing is that today, you know, people are developing their own processes in manuals. So I think we're not really that far away in terms of starting to implement the methodology or the mindset in terms of, okay, so you're doing your flow chart, but just think about, okay, what is the hazard of this specific process? And then start looking at interactions, looking at mental models, algorithms. I think this is why it may click like that whenever you're trying to implement your SMS in making sure that you have a safe, a controlled, safe system, right?
Yes. The other thing I'll just talk about, and I don't want to be too controversial, so please bear with me.
Go ahead.
So the concept of a safety management system, as defined in ICAO Annex 19 and in the EASA draft regulations, is the concept of the concept of an SMS and the focus of it and the recommended elements that one should contain. My interpretation, and I may be completely wrong, but my impression is it has originated from an operations type background and perspective, whereas I'm coming from a design for safety perspective. So
Absolutely.
I'm not going to assume anything about the thing I want to control. What are the elements of the control structure I need for those particular hazards? And, without knowing those hazards, you can't necessarily know what the control structure needs to be. I mean, you can have a good guess. We need somebody to do an analysis, whether it's a risk assessment, we need somebody to do some auditing, we need to do some investigations, and we need to do some safety information, or, let people be aware of what's going on. So they're your 4 pillars, but what other things might you need? And I'd argue if you come from an operational background only, you will think about things differently without necessarily that design, safety engineering design mindset.
Absolutely. And I can hear you, and I can relate to that, because the way my experience also is that in document 9859, which is basically the safety management manual,
yes,
4 pillars, and they talk about system description. And the way I try to cope with it is that they try to merge system safety thinking in an operational process that's been growing out of industrial safety principles. So, for example, a linear causal. And the way I see many airlines is, what is your system description? And they're like, yeah, no, I have to interact with ATC. But once you start understanding the system safety core concepts or system engineering concepts, you understand that this system description is basically what you should be doing with the STPA.
Yes.
You're not going to leave anything to chance. You just want to make sure that you're controlling your thing. And I think that the big the misconception perhaps induced by these guys, is try to implement a mixed theories in terms of system safety and industrial engineering to mostly industrial engineering people thinking, because with reason, with Heinrich, with the dominoes and the things, but this, as Nancy said in one of her documents, they came from the industrial type of thing where the worker was the pivotal point of the system.
Yes.
And I think that what they wanted to do with SMS is try to give it a system safety structure. Yes. And most SMS efforts are focused in the execution of the operation based on a model of system engineering.
Yes.
Really get to see that much, or actually have to see it. How do you design your system to be safe? You don't really get that. What usually airlines do is quality management systems.
Yes.
Again, there's many misconceptions in terms of what quality management is, because most people focus on ISO 9001, but they really lack the philosophy bring by Deming and the quality gurus in terms of understanding everything as a system. And Deming, in one of his books, one of the economics, I don't really remember the name, he was saying that describing his system of profound knowledge. Yeah. And one of those key issues that you need to do is have an appreciation for the system. That's it. And this is where everything starts coming together beautifully, because if you really want to have safe outcomes, you need to design for safe outcomes. And I think that's one of the things that perhaps Nancy was complaining a little bit about safety management too.
Yes. Yes.
It's okay. Yeah, you need to look at what's right, but make sure that at the beginning everything is on right, and you have your comparison. So it's complicated in terms of explaining this to people, but I think that's the way to go. And if you can actually have within your SMS, they require you to have safety risk management tools and safety assurance tools. Well,
yes.
Assurance usually are your reporting system, your investigation, your management of change, but your safety risk management at the beginning, it doesn't really state that well. And I think that STPA fits perfectly for making sure that you design an effective system.
I totally agree.
Absolutely.
One of the big challenges, and maybe I'll be a bit blasphemous now, but it's this concept of safety risk management. And the emphasis is on managing risks. Whereas in system safety engineering, we have sort of 2 distinct parts. We have hazards and hazard identification and analysis. And then we look at risks and risk analysis. But depending on, the part of the life cycle you work, if you work in, operations, there's not that much you can do to design hazards out. You have to basically deal with them. And then it becomes risk management. Whereas when you're designing a system, you have the luxury of, well, what are the hazards? Can we eliminate them and not worry about them? If we can't eliminate them, okay, what's the potential risk with that? And how do we manage that risk? And so you've got 2 handles to pull. essentially,
Absolutely.
if you think about system safety. But because operations, that's predominantly where the thinking has come from for safety management systems. It's all about risk management. So if they take a step back and realize, actually, we could do some hazard identification and management before we even think about risk. If there's an opportunity to eliminate it or reduce it, so the severity is not so bad, actually that's probably better than just living with the problem and hoping, guessing what the number is and, making numbers up, or, it's this class or it's this class,
No, absolutely.
And for complex systems, you can't put probabilities on things.
It's way too complicated. And that's also why I like the approach of STPA, because you don't really have to deal with probability. And I think this is one of the major concerns that you hear people talking about in the safety world is, how do you define a probability? Is that the same as uncertainty? Is that the same as frequency? How do you cope with the human fallibility to introduce your system? And I think that's not the way to go. It's just make it really hands-on in terms of identifying what needs to be done.
Yes.
Just to clarify that, not to clarify, but to emphasize the point in terms of SMS requires to do a system description. It's not a system design. Perhaps if they want to change the words to system design, many more possibilities could come. Because you said it perfectly, as once you start with an airline, the airline I work for has more than 100 years old. They've been doing the same things always. You just go with whatever you have. But support you in terms of imagining that you can actually change everything in the design, even though the airline is still working and developing and delivering services. So, that's the big issue that we have. And this is why I want to start working with STPA in terms of going into the design of safety critical processes. It could be, it's not going to be the whole airline, but the safety critical processes that we can identify and work on that. So
yes, start with a hazard, or start with an incident or near miss or accident that you can then use as a starting point. Practice and get experience with modeling the control structure, because that can be really easy or really painful, depending on how much detail you want to go in. It requires, quite a broad perspective on things. Even the label control structure, I've had conversations in my group about it. The label control structure means certain things to certain people in certain industries. In some cases, it can take on quite a negative connotation. And so maybe control structure, we could use a less sort of authoritarian sounding label, but also recognizing that when we're talking about social organizations, are we actually controlling people below us in an organization? Is it actual control? Is it not leadership and respect? Is it a leadership structure? Conceptually, you could talk about all of those things, but ultimately what we're trying to do is make sure that structure and the components within it are able to control that process.
We need to ensure that we don't set people out to fail. And that's the big thing at the end. Why, managers, directors, VPs get paid the big bucks. It's because you're actually, and perhaps they don't really understand it that way, is because you're an expert and you need to design the system in such a way that it's going to produce the results that you want.
Yes.
They're saying that perhaps 85% of these deficiencies are attributed to the system, only 15% to the worker. And this is where you get to see that the system plays a big role in terms of how you define it and what context are you doing. And the most important thing, which is stressed also in Nancy's book, is how the dynamic of the system is changing to make sure that you can stay on top of it. What we were talking about, Tempe, changing from 2 to 1, where is that management of change leading, and what type of decisions you're taking. So I think
it is, and it goes to, it points to an absence of what I would call a system architect, or a control structure architect. And that is a role, a person, a team who are not necessarily part of the operations control structure to control hazards, but they sit off to the side and they model the system as they want it to be or that it is, and then they shape it and change it so that it actually meets the intent of the operational goals, but also safety management. Now, you might say, some people might say, well, is that not senior leadership's role to architect their organization or their business? And you might say, well, yes, it is, but they're architecting a business to meet a need for a customer and create a business model that they can extract value from for the shareholders. And that objective, that goal, and the design of the organization, the business to achieve that is not necessarily the same as what you need for safety management. In fact, it could actually have some serious conflicts between making money and having a safe operation. And so the concept of a control structure architect, system architect, if you like, is the perspective that you need to balance between business operations and safety. But if you went into a business and said, well, who is this magical team or person? Where would they sit? And you might naturally say, well, it's the CEO. And I'd argue, well, the CEO might understand the business aspects, but there's no way they could organize and architect their business for safety. So is it the frontline workers that need to do it? Well, I'd say, yes, they need to be involved because they understand the physical process intimately, but they don't necessarily have the skills or experience to think about the structure, the big picture. And because they're effectively, not being funny, but at the lower end of the organization, yes, it's not in their pay grade to make big decisions about how the business organization should work. And there's a book by Jocko Willink, the ex-US Navy SEAL, called Extreme Ownership and the Dichotomy of Leadership. And he talks about these challenges about having individuals with extreme ownership leading up and down the chain. And what he's describing is precisely those behaviors that people need to be able to be adaptable and architect an operation that's, effective for the mission that they're performing, but also safe. But yeah, I could talk about that a lot. So does that, we talked a bit about with the three phases. So foundation phase, which prepares you to do the analysis, the modeling phase, which prepares the control structure model, which is focused on the particular hazards, physical processes, and whether you're looking at work as imagined if you're a designer versus work as done, or if you're doing an investigation or an audit. And then the next phase is the analysis phase. So I spoke about STPA. Part one of that analysis is looking at unsafe control actions. And then the second part is looking at how those unsafe control actions can occur. And that's based on that particular controller, but also the control structure contributions to that controller. Now, in the context of cast accident analysis, the analysis phase is slightly different because, as you mentioned earlier on, we're only focusing on particular control actions that we have evidence for. And those control actions, whilst you might refer to them as unsafe control actions in STPA because you're doing it before the accident has occurred, when you're doing the analysis as part of CAST, it's unfair to refer to control actions that contribute to an accident as unsafe control actions, because we're essentially judging, if it's a person that's involved, we're judging their actions as unsafe after an accident has occurred. And it may be that they took actions because they believed them to be the right and safe thing to do. They might even be following procedures, such as in the Uberlingen accident with the Russian crew. They were following their training and procedures. So from their perspective, their actions were safe. But we know after the fact that they contributed to an accident. So we refer to those as contributory control actions. Fundamentally, they're the same, but obviously we have to be mindful that we're not being judgmental and, using hindsight bias to try and justify things. So we, as part of CAST, we look at the controllers themselves and their behaviors. We look at their roles and responsibilities. We look at the control actions, contributory control actions related, and then we explore why did those control actions come about. Now, if you want to get really detailed, you could use an STPA, looking at the control loop and moving around it and exploring it. But that's not necessarily appropriate for CAST because you might not have the information available. You might not have the technical detail. You might just have a smoking hole in the ground and no evidence. So you'd just be postulating then. So what facts have you got? And then the second part of that CAST analysis is looking at the structure itself. So how does the control structure contribute to those unsafe control actions? I mean, fundamentally, thinking about control structures and controllers and their interactions across the hierarchy, it's the same thought process in any of the stamp-based approaches.
It's the philosophy, absolutely.
But it's the context of the analysis. If you're looking at an accident after the fact, you will only have some information available, not as much information as you should make available to do an STPA.
Absolutely.
And that's why when I teach and talk about stamp, I always split it into those three phases, because fundamentally the first two are the same.
Are the same.
You're just starting from a different level of knowledge and information. But when you're doing the analysis part, that's what sets STPA and CAST apart. But the thought process is the same.
It's the same. Yeah,
it's systems thinking, control structures, interactions, control actions. And it also, as a bit of a bonus, if you're using CAST accident analysis or using the mindset of what's the control structure, what are the control actions, what's the algorithm, mental model, feedback, when you're interviewing people, you can actually understand from their perspective where they think they fit in the control structure. And one of the mental models is, like in the case of Uberlingen, you had two air traffic controllers. One of them went off to the rest areas, so there was only one controller looking after two sectors. If you were to interview those two people and say, well, why did it make sense not to be looking after this workstation? The mental model is, well, we've been doing this for a number of years and it's allowed by management. We've got local agreement to do it. The regulator's not said no, so we're safe to do it. But actually now with hindsight, well, actually that assumption is not quite
How clever
true.
was that? True.
Yeah. But yeah, systems thinking, stamp control structure thinking is what I believe to be, it's going to change things, going to improve things
Absolutely.
Tremendously. But I think,
and also in terms of getting buy-in, in terms of people doing this, perhaps they also are arguing in terms of the times it takes to do either exercise. So, for example, and I know you've had experience on this. How much does it differ in terms of timing of doing like a regular 5Y analysis, with their flows or whatever, versus a CAST analysis? Because I don't know if it's that much really, but I don't know what's your perspective on that.
It's a great question. The answer is it depends. The thing to be mindful of is those three elements: foundation, modeling, and analysis. So you have to do the foundation to really set the scene. And depending on how practiced and experienced you are, you've got to get up that learning curve. But once you're sort of up that learning curve, it can be very quick. 5 minutes. You don't. If you're doing an accident analysis, you don't have to go into that much detail because you can see what's happened. You know what the loss is. I mean, the only exception is if it's a complex accident such as Fukushima or public health. Contaminated blood or the thing that shall not be named that's going on. Doing the control structure modeling, now that is a skill that needs to be practiced, and it comes naturally to some people, not necessarily to others. I do recommend I say the rule of three in the training. It literally just means what are the three obvious controllers involved in the control structure, and you can start from there. And even that simple step of defining a 3-layer control structure model can empower you to ask questions that you would never imagine to ask if you did a 5 whys. And you can build that model in 10 seconds. Somebody who's familiar with the process, they know who the key stakeholders are who need to be in the control structure. And it's only then, once that's built, you then start to ask questions about, well, what are the interactions? What is the information necessary for this person to be able to do whatever these actions are? And if you want to include, sorry, go on.
No, it's okay, because, and I'm thinking about like a parallel because using wise, you also need to have a foundation in terms of understanding the whole concept of the incident or accident. So I think that perhaps, and it's what you say, perhaps the more you manage it, the faster you might get your results. And
well, you could have someone who knows how to apply stamp, applies CAST in the meeting when the 5 whys is going on, and they could listen out and build the control structure modeling at the model while that's going on. because I mean, I don't know what 5 whys you would use, but it'll have like people, processes, equipment, maybe, and a few others. Those categories are potential candidates for inclusion in your control structure model. Like if a person is using, I don't know, they're going to blow the tires up on the aircraft, so they've got an air pump. You know, the air pump itself is an actuator for that person doing the task. And so if they blow the tire up with too much air pressure, you know, straight away you can look at that actuator. Well, was it an equipment issue with the actuator, or was it a control action from the person operating it? Well, if it was a person operating it issue, then, well, what is the sensory feedback? And in the case of a pressure device, it should have ideally a pressure feedback, you know, a pressure gauge or something. Well, is it calibrated? You know, so you can start to overlay those, you know, building the model and asking questions with the activity of doing a 5 whys or any other kind of investigation.
So perhaps it's going to be kind of like the same time and process, but I think that, and to your point, is that CAS is going to allow you to have more a broader aspect for asking questions.
Oh yeah, you ask questions you never think to ask.
The same elements, the same incident. The only way is how you start modeling is not just like a linear thing, but a more dynamic type of thing, which is going to help you out. And I think that's going to be taking a lot of time once you are familiar with the process. Yeah.
Well, it's the thought. I always say it's the control algorithm and the mental model of the person doing the cast or the stamp, or, you know, stamp-based analysis, STPA or cast. It is how you think about losses and hazards, and be mindful not to just focus on failures, because it's broader than failures. So that's the first thing. The second is how to think abstract about the control structure. So what is the physical process we're interested in? And, you know, what are the 3 basic controllers in that, candidate controllers in that structure? And if you start from that point, it allows you to ask questions as part of the investigation, and you can then make decisions about whether you expand that model to look at other things. A silly example is, you know, a maintainer repairs a particular product, it goes back into service, it's subsequently discovered as faulty. The investigation goes back to that individual operator that signed it off, and it's found that that operator is new to the company. So there's a question there, well, okay, if this person has put, you know, these contributory control actions are allocated to this person, we recognize that it could be anybody, not just that individual. But if we're talking about this individual, what is the control structure above them? How were they put into that position? And why was the results from their work not checked? Or if it was checked, was that check-in adequate for their item to be released from the factory? And is it just for that individual, or is it for any person? You know, someone who's had a long day is really tired and they do the same thing. Does it matter if it's a new person or a fatigued person or anybody? Absolutely. You know, and then you can look at the control structure. Well, what was the control structure that qualified and put that person in place? What was the training regime? What were the HR policies? You know, was there, you know, was this person redeployed from elsewhere where they were familiar with working on a process over there, but applying the same control algorithm to that process to this one, actually now that's dangerous. And then you could go even further and say, well, okay, how did we make decisions about that process and what the safe actions are? And how did we make sure people understood that this process over here, whilst it looks the same, there's a very important safety difference, and we need to put special controls in place for that. You know, absolutely. And I've sort of gone really far with that, but I'm just trying to sort of emphasize that you can start from something really, really simple and get some brilliant results. But if you want to go really far, you could, you know, really go to town.
The methodology allows you to go far. I think that's the best thing to keep in mind. Awesome. Yeah. So basically, those were the 2 basic questions I had in terms of, you know, I really wanted to understand a little bit more application on the real world for airlines operations, like not technical Boeing perspective, but airline actually performing and delivering services. and the times it took in terms of doing a cast and STPA versus what we have today. But I think I'm clear now with the explanations you gave me. So I really appreciate that.
Well, I must sort of emphasize that when you first start out, like with learning any new activity, you're essentially habit building how to think and how to do the process. And it's, that's kind of mechanical, but you've also got to get information, manage information, and then think, well, how does what information do I need and how does it fit? And then once I've fitted it in, now that I've done some analysis, what other information do I need? And it's the administration of that state of knowledge, if you like, that can be quite difficult and overwhelming. And so I always recommend start simple control structure. Don't go and try and model everything. Just start with a simple one. And then once you've developed and practiced those skills, then you can start to graduate to bigger, more complex control structures. Because the more complex it gets, the more information you need, the more information management you need, tool support. I mean, I use my iPad with a pencil because it's quick and easy to create the control structure models. But once I've built the model, I can then make it look nice using Visio. And we really do need tool support. And at some point, I'm sure something will come along. But until that point, we have to do it a bit manually.
It's simple.
But I do recommend doing it manually because you're building the thought, you're building the control algorithm in your brain. If you just go straight to tool support, it sort of crushes your creative thinking. And that's really important, that skill.
Absolutely. I hear you. Perfect. Awesome.
Yes.
Cool.
So what other questions have you got, or shall I pause it there?
Yeah, it's okay. No, I think I'm clear on that. So if you want, we can pause it there. And
okay. Awesome. So bear with me.